Okay, it's recording now. Great.
Okay.
Where's the tie?
Where's the tie? Huh? We are from the Middle East. We don't wear ties. You know that Zach and I, let's call it cousins.
Yeah.
Zach, where are you from?
Yeah.
Zach,
Where are you from?
Yeah. Well, I'm Syrian American, so half. Yeah. So. Yeah.
I used
Neemeh and I are.
I used to live in the Middle East. That's for another conversation, though.
Oh, where?
I was in Jerusalem.
Oh, okay.
Yeah.
All right. Uh-huh.
Neighbors.
Uh-huh. Yeah, I was living in Aleppo in Syria.
Oh man.
Yeah.
My heart goes out to you, my friend.
Yeah.
But you did came here as a small child, right? If I remember correctly.
What's that?
At which age did you come to the US?
Oh, I've lived back and forth. So I was here when I was younger, and then I went to the Middle East, and then I came back when I was much older. Yeah, so back and forth.
And it's so funny that although we like from, let's say, different countries, like no peace agreement and nothing, but still, you know, immediately I could see that we have a very similar attitude or culture, you know?
Uh-huh.
Yeah. Yeah. But okay,
All right.
never mind that. Yeah.
So let me get started with this. I have no idea if I'm going to be able to get through all of these, because I'm sure that you'll have lots of questions as I go along, because it makes a lot of sense to me, but it's probably very new for you. So anyways, this is something I've been working on and collaborating with for the last year or so. It's LIDA, which stands for Learning Intelligent Decision Agent. And this is in association with the Institute for Intelligent Systems at Memphis. So here's what I'm going to do. I'm going to give you a brief out. So LIDA it's more than that, but it's partially an implementation of global workspace theory, which is a theory of consciousness. It is more than that, but so because of that, I want to first give you a brief introduction to global workspace theory, because that's more general than LIDA. And then I'm going to look at a brief outline of LIDA. I'll talk about the level of modeling that we do in LIDA, which is, it's kind of an intermediate cognitive level of modeling. It's different than what Neemeh is doing. Neemeh is doing a much lower level of modeling. I'll explain what that means when we get there. And then I'll talk about what are called cognitive cycles. And that's mostly what my talk about the LIDA aspect will be. And then hopefully we can get to an example of one simple example of what being conscious of one specific thing would be like in the LIDA model. Okay, so global workspace theory. It's one of the largest empirical theories of consciousness. I mean, it started in 1988, and it's still a huge one, and other competing theories have really borrowed a lot from it as well. So basically, it's a cognitive and now also neural theory of functional consciousness. And when I say functional consciousness, I mean consciousness insofar as it has a causal role in a cognitive system. So we're not talking about phenomenal consciousness here. It's not really a theory of why we have, why there's something it's like to be us. It doesn't really have anything to say about that, which is unfortunate from my perspective, but you know, you have to start somewhere. So it's all about really the idea that consciousness has a functional role ultimately comes from William James, you know, back in what, 1890, you know, who said that consciousness evolved for a function, and our task is to figure out what that function is. And global workspace theory kind of runs with that idea and says that, yeah, no, consciousness is not something that we would say is epiphenomenal or just, you know, has no causal role in the system, but actually plays a really important role. Some of the most important figures in global workspace theory you might have heard of, you know, Bernard Bars, who's the one who started it all. Stanislas Dehaene, he's also a big figure in there, who's kind of been big in the neural implementation of this. And then there's also Stan Franklin, who does LIDA. So it's from a computational standpoint.
I'm not familiar with these names.
Okay, yeah.
Yeah, only Bars in the hand.
Uh-huh. So the idea in a nutshell of the global workspace theory is that consciousness doesn't have a single locus in the brain. This is similar to what Dennett's critique is of what he calls the theater of consciousness. The idea is that there's no central place where it all comes together. As if we could just, you know, like once upon a time, Descartes picked out the pineal gland as a really important place where, I mean, it's not really where consciousness was because he thought it was immaterial, but at least it was an important part of the brain where it all comes together. And for global workspace theory, there's not one place where it all happens. It's not a magic theater. It's really distributed across not the entire brain, but important large swaths of it. Specifically by thalamocortical networks. So really you have cortical regions widely involved. You also have, you know, the two thalamuses involved, which are, you know, kind of these dense relay stations for sensory information, you know, mediating that information going to the cortices. And, you know, of course, the thalamus is involved in wakefulness, but cortical networks are also widely involved. So, you know, no one specific place where it all comes together. That's you know, different than some other theories, for some higher order theories, for example, that might say that prefrontal regions are really important or whatever.
Even here, they don't speak about subcortical. I mean, we don't know.
What?
Maybe consciousness somehow related to subcortical places. I don't know, like the colliculus or something like that, right?
Yeah.
The amygdala, you know, all these parts.
Yeah, no, I mean, subcortical regions can also have an important role to play. The important, I'm not getting into the details here. The important point is just that, you know, it's widely distributed, right? Yeah.
Right.
Now, one of the important aspects of consciousness is that it has very limited content, but it makes that content globally accessible. Globally accessible to what? To different regions of the brain. So here's an example. Take a look at this. What do you see? Nir, what do you see?
I see a house.
Yeah.
And actually, well, because I'm outside, it's hard for me to see
Okay.
because I have lots of sun, but it looks
Yeah.
like a house, and what is it, like a water there or something?
Yeah.
And the tree and the sky.
Yeah. Okay. So it was a pretty rich visual experience, right? Yeah, but where was the dog?
There was a dog over there?
The dog was in the lower left corner.
Okay, so Dina,
Birds
is
are
that
in the
how you
sky.
pronounce it, Dina?
Yes.
Yeah. So Dina saw the dog apparently.
Can we saw it?
I'm an artist, so
Okay, so that's not fair.
I knew where it was going, so I was scanning all the details.
Okay, yeah, no, that's not fair. I want naive observers here.
Well, but you know what? As I told you, because of the sun, even now, I hardly can see the dog. Where is he?
Over on the lower left corner. There's a man there, or, well, I guess it could be a woman. There's a person there.
I don't see it.
You know, Zach, when I was reading up on
Yeah.
links that he sent, that Nir sent us about,
Yeah.
you know, the underpinnings of this theory,
Yeah.
my first thought was, well, then how does encyclopedic and visually encyclopedic memory work? I understand that that might not be the same as consciousness, but if you could at some point speak on that, that'd be really interesting.
What works? I didn't understand what.
On what?
Some people have total visual recall of
Oh,
memory.
yeah.
And in hypnosis,
Eidetic memory.
yeah, and in hypnosis, you know, you can also access incredible detail. And some people have encyclopedic memory. So at some point, it'd be interesting just to touch on that, you know, how that works.
Yeah, yeah. So eidetic memory it's definitely a pretty rare phenomenon. The point that I want to focus on here is because I don't want to focus on this aspect, is that consciousness is typically pretty circumscribed in its contents. So you see a really rich visual scene in front of you here. And at least for most of us, we're not taking it, although it seems like it's very rich, we're really not seeing most of the details at any one given point in time. It's only over a really long period of time that you can truly appreciate all of these details. And it's really just by serially scanning them. You know, you're taking these things in one at a time. When I'm looking at the dog, I'm not looking at it's actually a watermill. Is that what you call it? And when I'm looking at the watermill, I'm not taking in the dog. So the contents of consciousness are pretty limited in that way. But they are made globally available, and that's the important thing. So we take in a very limited amount of information at one given point of time. But what the global conscious broadcast is basically the idea that this information is made available widely to different brain networks. So this is one illustration of the idea. Basically, you see up at the top, can you see my cursor?
Yes, you can see.
Yeah, okay. So you see up at the top, you have things like outer senses, you know, hearing, seeing. You have inner senses like visual imagery and speech. You have ideas. All of those are potential contents of consciousness. Now, they're potentially contents of consciousness insofar as they're not necessarily operating consciously, right? But once we focus attention on them, they do become objects of conscious experience. Now, the idea is that once there's this attentional focus on certain contents, then it's made available to memory systems, to different interpretive systems, to, you know, embodied skills, regions involved in embodied skills, I mean, for motivations, for all of that. So it's basically a way of connecting distributed regions of the brain. You know, you can have widely divided regions that are essentially communicating to one another through the medium of consciousness. How does that work? Well, it's basically through nonlinear dynamics in the brain. So neurons are nonlinear oscillators, right? They oscillate to certain frequencies. You know, they have pulses. And neurons can together synchronize their pulses, especially through hierarchical mediation of long fiber pyramidal neurons, which connect widely distributed regions together. So basically, when you get some synchronized neurons, you have a local neural assembly, which is evolved in unconscious cognition. Now, when you get a group of local neural assemblies that begin to synchronize together, temporarily, of course, what we have is a formation of global neural assemblies, which is across, not the entire brain, but very wide regions of the brain. The idea is that this is essentially what the global broadcast is. You have synchronization of neural assemblies, and that's how content is made available to different regions. What kind of synchronization are we talking about? Basically theta gamma wave couplings. So the idea is that these, especially gamma waves, but other waves as well, mediate the coupling of these different neural assemblies. And when you have a single conscious broadcast, where you have a global synchronization of different neural assemblies, you also have an active inhibition of competing neural assemblies. So that makes consciousness into at least a functionally serial process. Consciousness, it always scans one thing to the next, one thing to another.
Because of the inhibition, so you only can scan one thing at a time. This is what
exactly.
You mean?
There's one global broadcast at a time, and that's really rapid. I mean, you're going to have tons of global broadcasts one after another, but they're coming one after another. They're not all together, like you would have with unconscious cognitive processes. Unconscious cognitive processes, everything is just happening at the same time. Why? Because every region is doing its own thing. Early visual processes or auditory processes, all of that, they don't, at least at the early stages, they're not relying on one another, right? They're doing their own thing. So they're parallel in that sense. They're acting together. But at the conscious level, you're getting essentially one thing at a time.
I see, nice. And by the way, do we know why it has to be like theta and gamma?
Why does it have to be that?
I mean,
they're just particularly associated with conscious states. There's good evidence for it, at least. Yeah. Now that's really, I hope the idea is clear. I don't really want to get into the neural aspects any more than that, because I want to talk about LIDA, which is not a theory of the brain. It's a theory of the mind. But I hope the idea of consciousness as a global broadcast is clear to you. Let me know if it's not. I mean, the idea is simple, really. It's just that content here can be broadcast everywhere, right? So that being said, let me go to LIDA.
Right, you know what? So why?
Yeah.
I do have a question. So why do they think this is good explanation for the functional part of consciousness? It just seems like good explanation for, I don't know, I guess integration of faraway areas and do like a serial processing.
Yeah, so that's what the function of consciousness is to integrate widely distributed areas and to allow other regions to gain access to that content. That is the functional role, according to global workspace theory. And obviously, the phenomenal level should be correlated with that, but it's not specifically a theory of phenomenal consciousness. But you should be phenomenally aware of anything that's being broadcast. That's at least ideally, yeah.
Right, because we learned that William James actually suggested
Yeah.
that for consciousness, we need like the connection between the agent or self and something like other representation, like the senses or something. And here they don't speak anything about it, like about this like connection between like an agent or something like that.
Connection between the agent and what?
And the other representation, like the senses, like visual input, for example. The connection between the self and visual input, for example, or some other input. Because when we see something
Yeah.
in the consciousness, we will say, you know, it's not just green. It's, you know, no, let's say, I see green, right? It's like always we have this relationship to the self.
Yeah, so the self, where does the self come about? Maybe I can show you in LIDA how that comes about. Let me get into the specifics of LIDA because it is a model of global workspace theory. So hold on with that question. Hopefully I will answer it. And if I forget to answer it, remind me. But just give me 1 second.
Sure, no problem.
Okay, so LIDA is, well, it's a functionally conscious cognitive architecture. Again, functionally conscious meaning that it has all of the computational aspects of a conscious system. There's no claim that it's phenomenally conscious, though. And what exactly is a cognitive architecture? Well, you could think of a cognitive architecture in contradistinction to a cognitive model. So a cognitive model is a model of a specific cognitive function, like working memory, for example. You might be familiar with Badley's model of working memory, you know, where you have these three elements that come together in a central executive. Now, this is a cognitive model because it really gives us a picture of only one process, but it tells us nothing about how that process connects to other things. The idea of a cognitive architecture is that you can't proceed like that. Who was it? Alan Newell, I think, who once famously said, you can't play 20 questions with nature and win. And his idea was that you can't just pick apart different cognitive models of specific processes like working memory and visual processing and all that as if they were disconnected, because if you don't know the connections, you actually don't know how the process itself is working. That's the idea of a cognitive architecture, is that you have to have a holistic model of an entire mind. So LIDA aims to be just such a holistic model of the mind. And it implements global workspace theory, but it also integrates a lot more elements. You know, it integrates lots of other theories from psychology and neuroscience as well. It aims to be basically a cognitive theory of everything. That's a big aspiration, and obviously that's an ideal rather than an achievement. But
well, this is exactly what I try to do, right? So.
Yeah. And let me comment on the word mind. So, you know, when I was talking about global workspace theory, I was talking about the brain mostly. When we're talking about the mind, we're at a higher level of abstraction here. We're talking about the abstract computational structures. They could be implemented in brains. It could be implemented in computers. In fact, that's exactly what LIDA is implemented in, is in computers. Could be implemented in anything. So it's a higher level of modeling. And when I said a cognitive architecture is complex, this is what I mean by complex. It's instead of a couple things, we're talking about, you know, a very large, complex structure. Now, the level of modeling that we're doing is the cognitive level. So I think Neer's theory is probably right here, you know, at the level of attractor landscapes and nonlinear dynamics. LIDA is at a higher level of abstraction from that, which is the cognitive level. It's neutral as to how these cognitive structures are implemented. It could be implemented by not only at the lower level by brains, but also at the higher level by nonlinear dynamics. But that's not what LIDA is modeling. It's modeling something at a higher level of abstraction than that. And there's important reasons for that. We think you need a model of every single level. Why? Not only do you need a model of, you know, how neurons are interacting, you also need a model of the more abstract attractor landscape. But on top of that, you also need a model of how different computational functions are interacting with one another. Because some of those details can get lost when you have a very microscopic focus. It's kind of like a microscope, you know. If you're looking at you know, some little organelle of an organism, you might miss the entire organism, right? And that's the idea of a higher level of modeling here. Now, I don't think I need to talk about that. All right, so the basis of the LIDA model is what are called cognitive cycles. And a cognitive cycle is basically like a perception action cycle. You know, you see something, you get a conscious broadcast, and then you take an action upon that thing. And these conscious or these cognitive cycles, they're asynchronous. You know, they just, it's not like you have to wait to see one thing and then act upon it to initiate another cycle. You know, you see something and then you eventually act upon it, but in the meantime, you see another thing and another thing. They're just happening one after another after another. In humans, an entire cycle like that, from perception to action, can take between 260 to 390 milliseconds. I give the human as a reference, but LIDA is not a model of humans only. It's just a model of minds in general.
But I have a question.
Yeah.
We know that we can do like perception and action without the without consciousness in humans. Mm-hmm. Will it be like a cognitive cycle as well, or something different? Because
so there are some. Usually, so there are ways that action can bypass consciousness in the LIDA model. It's just that a lot of things don't bypass consciousness. So, at least as far as action is concerned. But yeah, tons of things also do. You know, there are things like automatized actions, and for example, alarms. If you throw a ball at my head, I don't have to wait for a conscious broadcast to react to it. If I did, I wouldn't be able to dodge it in time because it would just take too long. It would be too many milliseconds. Yeah, so there are ways that the cognitive cycle can be bypassed, basically. But still, overall, it's a good way of explaining the model. So there are three phases of an entire cognitive cycle. There's a perception and understanding phase. Then you have an attention phase, which is associated with consciousness and broadcasting. And then you have an action and learning phase, right? Which is, it's not complicated. It's, you see something, you're aware of it, and you act upon it. So this is a schematic of what the LIDA model looks like. Don't get too scared by the complexity. I'll try to make it sound sounds comprehensible. So basically, a cognitive cycle is going to work counterclockwise. Let me see, how does a clock move? It moves like this, right? Yeah, so it's going to go clockwise. So you're going to start with a perception and understanding phase right here. You'll get to an intention phase over here, and then you'll initiate the action phase over here, and then it'll just start all over again. So let me explain this. So the first phase is perception and understanding, which in humans, it's about 80 to 100 milliseconds from the time that you're given a stimulus. So basically, you can see my cursor here. You have a stimulus in the environment, and that stimulus is going to act upon your sensory memory. Sensory memory, it's a rapidly decaying form of short-term memory. Basically, it has really basic feature detectors. It can be unconsciously primed. Its basic structure is basically computationally a neural network, but in humans, you could say it's correlated to early visual processes, though it deals with all modalities. So it's an early form of processing.
Like for feature detection and stuff like that, I guess.
Really basic feature detection. And it's very rapidly decaying, but it's also very high capacity. And then once you have that very basic level of processing, it's sent to what's called the pre-conscious workspace. The pre-conscious workspace, well, what does pre-conscious mean? It means capable of becoming conscious. So things that are sent to the pre-conscious workspace are at least potentially conscious, but they are not yet. Basically, in this workspace, you're going to have down here a model of things like the agent's environment. You're going to have a model of even the agent's position within that environment. You'll have things like also ideas and thoughts as well. All of that is floating around in what we call the situational model, the current situational model. And it's building up not only a representation of your world and your place in the world, but also, simulations that you can perform on that world. So not everything is necessarily real in there. So you're slowly building this up. Now, none of this is conscious as it is. It's an entirely unconscious representation of all these things as it stands. Now, how is this model built up? Well, first of all, let me say that it's a form of short-term memory. Our model of how things are going is constantly being updated at every second. So there's nothing that's long-term in that. It's continually changing as our environments change and as we change. But how we build that model is through long-term memories. And we have a whole host of long-term memories. We have one that is, for example, recognitional. It's dealing just with recognizing objects and actions and things like that. I can see that as a stop sign, for example. Allocentric spatial representations is another form of long-term memory. The way things are positioned, not in terms of my body, but in terms of themselves. That's long-term rather than short-term. There are other forms of memory, like, I won't talk about all of them, but declarative memory, which is, it's like you have you have episodic memories, and you have semantic memories. And semantic memories are basically episodic memories that lose their specificity. And it's all there in this declarative memory. And all of these are, as you can see in this larger diagram, they're in the center here, those long-term memories. And they're feeding back and forth between our model of the world, helping us generate that representation of a situational model. You know, so I have a model of my situation, but it's being informed by things that I've stored in long term. Does that make sense so far?
Yes, I have to say that I don't know about the others, but from the papers that we read here in the Journal Club, and also from the classes that I took this summer about concepts and unconscious, it's really resemble the cognitive theories about how the brain works, how we create concepts in the working memory from the long-term memory. It's really very much like what we think about the brain, about our mind.
Yeah, so I have two things to say about that. One is that it should, if we're doing things right, it should just make really a lot of sense with the data that we're working with. The idea is that this is a holistic model of a mind. So instead of being surprising, it should make everything make sense together. Second, it should work for humans, but it should also work for animals and for computers and robots. So LIDA agents can be anything. And if you have a robot agent, it won't necessarily need all of the modules that you'll see here. You know, different minds could be different. For humans, we're going to need all of that you see here, but you know, maybe an animal doesn't need some of all of these. So it's not specific to humans, though it should explain humans as well. And also, you notice there is no working memory here.
Zach, I have a quick question.
Yeah. Go ahead.
Thank you. Quick question about the chart. So in the chart label, in the key, conscious is kind of an orange color.
Yes.
So it just means that consciousness is simply a process. It's not a place, or it just happens as a process between all the elements.
Yes. Basically, yeah. Right. According to the global workspace theory, there's no one place where it all comes together. You know, there's no place in the brain that is conscious. It's widely distributed networks that are conscious, rather. So yeah, it is more of a process. I'll get to that in I think a slide or two.
I have also a question. I mean, so you said something that there is no working memory, but this is exactly, I mean, what you showed us before, the workspace, the current situational model. I mean, so this part is like
it correlates
the model
to
of
memory.
Yeah, isn't it like what you showed us before, the model of working memory in humans?
So it's to contrast it, you know, this is working memory. You don't really have any of the distinctions that I made here. Working memory is something that its contents are conscious, according to Badley, right? You can always report on all those contents, and they're conscious. The situational model that you see here, the current situational model, is not conscious. It's what we call pre-conscious, which means elements of it could become conscious. So there's something different here. It correlates to what people talk about with working memory, but there's more subtle distinctions that we make, precisely because we're thinking in terms of a system instead of just a module, right?
Right.
So,
So to build a model, okay, yeah, it's part of like short-term memory also to build a model of like the current situation.
yeah,
So it's something that should be part of the like short-term memory, I guess.
yeah. Look, think of it this way. It should also make some intuitive sense. Like, uh, if you when I turn around my head, um, the contents of consciousness are different. I turn my head the other way, the contents of consciousness change. But I still know what's going on in the situation. Like my representation of the situation of my room and me talking to you all is not changed. So contents of consciousness shift, but you still have a more stable model that's underlying some of these things. That I may not be aware of it at every single moment, all of the aspects of that model, right? Now,
Right, you're right. Yeah.
Now, at this point, we get to the attention phase. Whoops. Yeah, which in humans is about 200 to 280 milliseconds after the stimulus onset. And basically here, you're going to have attentional processes that are looking at the current situational model, our situational representation. We call these attentional codelets or attention codelets, but basically it's just what we're talking about is you have attention that's being put on some of the elements of that model, right? So you have different attentional processes that are all looking for their own concerns. Some attentional processes are interested in loud things. Some attentional processes are interested in bright things, right? Some things are interested in dangerous things. There are all these little attentional processes are working from the bottom up to find what interests them. And they're going to basically create what are called coalitions. So if an attentional process finds something within your situational representation or model that is, say, highly salient, it's going to form a coalition. And that coalition is going to compete for conscious broadcast.
What does it mean to form a coalition?
Yeah. So a coalition is basically some structure that you have in your situational model that has an attentional process that's looking at it. That's just what it means. It's just a technical term. Yeah.
Okay, like the interaction between the...
Like you have, let me say, like, what would be an example? My hand is something that's a structure that's represented in the current situational model, okay? And if I pay attention to it, then that's what's called a coalition. So it's not a coalition until I pay attention to it. And that coalition can compete for consciousness. So that's the central idea of global workspace theory, is that there's a competition for consciousness. So you have all these bottom-up processes. Everything that I'm talking about so far is all these low-level bottom-up processes that are creating emergent, models of the world, and the attentional processes are all bottom-up as well. They're going to start competing.
So there is no... So according to this theory in LIDA, there is no consciousness without attention, right? Because with attention, you need to create this coalition, and they are the one that will compete consciousness.
Yeah.
So you have to have them.
Of course, we're talking about bottom-up attentional processes here, not top-down. You can also, intentionally focus on something, which is top-down. And what I'm mostly talking about here is just the kind of low level things, you know, that are causing us to attend to things. So you find some structures that are highly salient in your world, you know. I see Neer moving his mouth, and I hear words that are coming. Okay, that's something that's highly salient, and that's going to compete with other elements of the screen. Okay, so while I'm focusing on Neer talking to me, I'm not going to be focusing on the word attention codelets in the corner. These are things that compete for each other, right? So the screen in front of me is competing with the words that Neer is telling me. And that competition is going to basically, whatever wins out is going to be the thing that's most salient at the moment. Whatever has the highest level of activation it's what's going to win and be conscious. And that's what the global workspace is. It's just a place where different coalitions compete for consciousness. Whatever has highest activation wins. You know, so if it's somebody talking to me, that's probably going to be highly salient. If I see, you know, if I hear ambulance horns blaring, that's probably something that's highly salient. And those are going to win the competition, and you'll be aware of them. Whatever is less salient to you, you won't be aware of at the moment.
Zach, within the framework that you're discussing, can you talk a little bit about the difference between consciousness and cognition?
Yeah. So cognition is the entire model that you see before you is cognitive. And sometimes the word cognition is only used to pick out higher order things like language, but in this context, cognition refers to anything that is perceptual or related to action as well, in addition to traditional, you know, higher order cognitive processes. So everything here is cognitive, but only a subsection is conscious. Specifically, whatever wins out the competition for, you know, whatever is most salient to you at the moment is what's going to be conscious. So not all cognition is conscious, but all consciousness is cognitive in that sense. So it's basically one of these is a subset of the other. Consciousness is like a subset of cognition. Sorry, what was that?
Yeah, I just wanted to say that this is what we read about the three-tier model, actually. Over there, we started from sensation to perception,
yeah,
and then to cognition. And
yeah.
so cognition was when you have representations that the system recognize, you know, recognize those representations, and it can be used even if there is no inputs outside, right?
Yeah.
It can be used as a mistake also. So when you have this, you know that you have cognition. And consciousness only will come later on. So a bit like here, it's like subsection of cognition, but also maybe perception. So yeah, maybe. But it's very resemble.
Yeah, it's a consciousness is a subset of cognition, and remember, I'm using the word cognition to include perception and to include action as well. Not everybody defines it in that way, but that's how we're defining it.
I see. And by the way, before when we spoke about the brain and about the synchronizations between the neurons in order to create, so this is, I guess, let's say the mechanism of how to create more activity that this coalition will win. So
yeah, in a human brain,
in a human brain.
the coalition, you know, in the LIDA model, this is all just it's a higher computational model. We're not modeling you know, brain dynamics, but in a human brain, how this would work, this competition for conscious broadcast that I'm talking about, how that would work is basically some of these neural assemblies, which are basically groups of neurons that are synchronized um, together, you know, because neurons oscillate and they temporarily oscillate to each other's frequencies. That's what's a neural assembly. That's how they emerge. And then these different neural assemblies, some of them have higher activation than other ones. Some of them are more, they have stronger capacity to make other 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 neural assemblies oscillate in the same frequencies. What gives them this power? It's usually attentional processes that are really decisive for this, which is really related to saliency, you know. And that's part of the functional role of consciousness, is to pick out really salient things and make them available to other networks. So yeah, mechanistically in a human, what I'm talking about would just be, you know, some lower order representation that's not conscious yet. Because it's highly salient, it just gains massive appeal throughout the brain and starts, you know, a global synchronization. Yeah. So in the global workspace, coalitions compete with one another, and whatever wins is conscious. And that consciousness is referred to as broadcasting. Why is it broadcasting? Because other modules can see what's going on. And that's what's represented in the chart here with the orange lines, which are conscious processes. This is what you'd be conscious of is, yeah, it's basically just processes here. And you're making available to other modules what's going on in that coalition that's winning. So when I see Neemeh making, you know, movements with his mouth, and then I hear words that are associated with it, that's highly salient to me. And I say the word me, but of course there's no, the only me here is the system itself. There's no me inside of the system. I'm just using that as a linguistic nicety. But when Neemeh becomes salient to me and is broadcast, then what's going to happen is that will allow me to take actions, first of all. So I can respond to Neemeh, for example. I won't be able to respond to Neemeh in the same ways if I'm not conscious of him talking. That should be relatively intuitive. If I am not conscious of Neemeh speaking, I will not be able to process his sentences. And if that's the case, you know, I'm not going to be able to take the same actions that I'm taking, which is responding to him verbally. You know, so I can act upon things that are conscious, and I can also learn from them. So there's two things that are going on. Yeah.
Quick question. So I've heard the word serial come up a few times in the slides.
Mm-hmm.
Is the idea that the conscious lines here are not, you can't do multi-threading, or is the idea is that they can only fire one at a time?
Yeah, they're one at a time, basically. Yeah, but they're extraordinarily rapid, one after another. Yeah, but basically one at a time.
Why not have a multi-threaded theory? What's the hindrance on that?
Well, there are neurological and phenomenological reasons not to have that. So, neurological reason is that when you have a conscious broadcast in the brain, there's when you have a global neural assembly that's synchronizing and firing at one point in time, it's actively inhibiting other neural assemblies. This is interpreted as evidence that there's one conscious broadcast going on at any single time. Everything else is relegated to unconsciousness. And those inhibited processes, they might be broadcasts right after the other one is done, you know, so you can be aware of it afterwards, but they're not happening at the same time. So that's the neurological evidence. Phenomenologically, it should hopefully make sense that you can only attend to one thing at a time. If you try to listen to me and to listen to another person talking at the same time, you're not going to understand what's going on. You'll only be able to understand one person.
I've heard that stated, you know, in many places, but it doesn't necessarily match up completely with experience. And there were people like Da Vinci who could write two different things at the same time with two different hands. And one of the reasons I brought it up is because multi-threaded is a really important concept in computer programming, of course, but also because of my meditation practice, which teaches something different than what is being said here. So I'd like to dig a little deeper and hear more about it.
Yeah, I would say that multi-threading for consciousness is impossible. Anything that you might experience as attending to two processes at the same time is simply because we're talking about higher timescales. So I'm talking about a single conscious broadcast. If you feel that you can attend to two things at the same time, what I'd say is really going on is that you're rapidly switching between two things. So it would be one cognitive cycle is focusing on one thing, but you might have 100 or 1,000 cognitive cycles that you're talking about, you know. So when we talk about our own introspective awareness, we're talking about long time scales that involve tons and tons of broadcasts. So any kind of evidence like that would just be explained by you know, there being multiple cognitive cycles that are going on. Yeah. So basically, everything in the LIDA module is massively parallel, except consciousness is one at a time.
I have something to add here.
Yeah.
The neurological reason sounds reasonable to me. Let's say even not only because of these inhibitions, but also because when it's broadcast globally, so many parts of the brain doing the same thing that, you know, you can do only one.
Yeah, exactly.
Time, you know? So this it sounds reasonable, let's say. About the phenomenological case, here it's a bit, I think it's too much, we do like a mistake here of taking attention and consciousness a bit too much as the same thing or almost identical. And I have two examples that I just learned a couple of weeks ago to show why it's not the case, at least in humans. I know it's not LIDA, but, you know, let's go to the basics, right? To humans for now. So two things. There is this, I think, experiment called the Sperling experiment.
Yep.
It shows that we have in consciousness much more capacity than what attention or invoking memory can do. So it's like it splits. It shows that working memory and attention are not the same as global workspace and consciousness. So the idea there, let's see if I remember, but the idea there is that you have a couple of rows that you can see and lots of like symbols.
Yeah,
Like, let's say,
my friend has been working on this, and yeah, he actually did the experiment on me and let me do it. Yeah,
cool.
you have rows of letters, and
Yeah.
they're presented in just I forget how many milliseconds, but it's very briefly, and you're attending to there's a little place in the middle that you're attending to, and then you have to try to report as many letters as you can, and I mean. In the beginning, you're really bad at it, and you can't report very many. You gradually get better. I certainly got better as time went on, but you still can't report all of them.
So, but the point is different. So yeah, you have like 5 rows, I think, and then so it's like a lot of symbols. And but then they did something more very sophisticated.
Mm-hmm.
Before you see for a couple of milliseconds all those symbols, you hear a tone. And the tone can be either high tone, middle tone, or a lower tone. Okay?
Mm-hmm.
And then according to the tone, you need to say the symbols in the higher row, or in the middle row, or in the lower row.
Mm-hmm.
Right? And then, so you hear the tone.
Mm-hmm.
No, first of all, you see for a couple of milliseconds, then you don't see it anymore. Then you hear the tone, and then you need to say, what do you remember?
Yeah.
So people can remember those 5 symbols in the higher, or in the middle, or in the lower, according to the tone.
Mm-hmm.
So it means that, before the tone, it has to be that they remembered all of them, all of the symbols at once, right? And then after the tone, with attention, then they remember only the 5 in the upper, let's say, row. And then they will not remember all the rest, So again, attention is very limited. Only, what was it, like 5 to 7 symbols. Yeah. But it seems that in this global workspace, in consciousness, we do have the capacity to remember something like 32 symbols. That only after the tone you will, with attention, you will go to one of those. So this is more or less.
Yeah. So, first, how would something like the Sperling experiment work in LIDA? You'd have most of this would be in process early on in sensory memory, and then you'd have some of this in the current situational model. Only a subset of that would be broadcast. What's going to be broadcast? Well, you're going to have a mixture of some elements which are symbols and some elements which are just perceptual. So when I see the Sperling thing, the numbers or letters flash, I know I can repeat a few of those letters, and I know that I saw more though. So I was aware of more than just the letters that I saw. However, that doesn't mean that I was aware of what letters they were. That requires, certain amount of recognition. We don't actually know if those are recognized or not. It might be that there's simply not, that we only recognize a few of those letters, and the rest, they just remain sensory elements. So all of that, a few letters and some more just vaguely sensory blotches are being broadcast. Some of those are associated with the tone, some of them aren't. Yeah, so I don't think that there's any problem for, LIDA for understanding Sperling. We have a guy who's been working on this, actually.
But notice that, first of all, you see all the symbols, and then, people can say, I remember that I saw more than 5, right?
Yeah.
But only after they hear the tone, it means that they need to have all those letters already in their memory somewhere. Yeah. In order to, after the tone, to unconsciously, to do all the processes in order to say which symbols they saw in, let's say, the lower part, right? Or the higher part. So they do need to have all the information in the memory before they can, with attention, can say only part of it. And because they say that they remember much more, so it seems that in consciousness already, they did have all the information, you know? So like consciousness has all the information and
Well,
attention will, you know, something like
I
that.
think, so what I'd say is that if everything is being recognized, that doesn't mean that it's conscious. You know, all recognition is, it's happening in the current situational model. Ultimately, you're building that kind of recognition of your situation. Only a part of that is going to be broadcast. So if you hear that tone and that tone tells you, you know, well, we have to broadcast only the first line of this, that's what you're going to be broadcasting. That's what you're going to be conscious of, right?
Right. So you think only after the tone it was broadcasted, not before?
You'd probably
This is
be
what you
already
think.
broadcasting through a different, through an earlier cognitive cycle, the visual elements or something. Only later would you broadcast something that's specifically triggered by the tone. So you'd have multiple broadcasts here, one after another. Remember, these things happen really rapidly, one after another. Yeah.
Right. So because you
But
can say that
so
you remember, yeah.
yeah. So try to do the Sperling experiment while you have a conversation with me. You can't do it. That's the point of consciousness being functionally serial, is that while you can do multiple things unconsciously, you know, you have sensory motor processes and you have early visual processes and you have a whole host of things that are happening all together. But when you're talking about things that are conscious, you can only do one at a time. You can rapidly switch back and forth. That's certainly possible. But, you know, yeah, you can't do the Sperling thing while you talk to me.
Yeah, that's true. That's true. It's more, you're right. I mean, this example is more to say that in the broadcast, we have more information than in attention. And it's less about serial and parallel processes. It's a bit different argument. Yeah. It's more about that attention and working memory are not the same as consciousness in broadcast.
Yeah. So I mean, in LIDA here, what we're saying is that attentional processes have to be attached to anything that is broadcast. So if you're talking about things that are on the fringes of awareness, there would still at least be a minimal amount of attention that's being garnered to them. That's the idea here. It might not be that you're focusing on that, but yeah, it has to have some kind of attention associated with it. It's just, I think what you're saying is that not everything has to be the focus of attention, which, yeah, that makes sense. I mean, but yeah, I think that's all accounted for. Yeah.
Can you talk just a moment about the difference in this theory between awareness and consciousness?
Between awareness and consciousness, awareness sounds like a higher order thing to me. I'm not sure exactly what you mean to pick out there.
You've made the current situational model as analogous to consciousness.
No, it's that's a situational representation of what's going on, and aspects of that can become conscious. So we're never entirely aware of our entire situation, but we can become conscious of parts of it. You know, like here in this diagram, you know, you have the current situational model, which gives you basically a model of yourself and your situation and everything that's going on. But the contents of consciousness are going to continually be different. You know, as you're looking at the screen, you still have a certain level of knowledge that you're in a certain room and, in a certain place, even though you might not be at every single moment in time conscious of those aspects. It's still part of a more general model of what's going on.
But you know what? This is a good question, because this is exactly what I tried to say with the Sperling experiment.
Uh-huh.
So I'm not sure. I mean, sorry that in Hebrew we'll say, sorry that I dig so much about it.
Yeah.
And these days it's become like a negative thing to say, oh, you're such a digger, but never mind that. When what I learned about cognition and consciousness, and not about LIDA, is that we can define the difference between consciousness and awareness, exactly the difference between, you can have consciousness without attention, and then it's just consciousness, but if you do have attentive towards something, then it's you're aware of it already.
Yeah.
So like
here's what LIDA would say about that, is that you are attending to everything that is conscious, but it might be that some of those elements, there's two things here. Some things have higher attention than other things. A second aspect is, we're talking also about multiple cognitive cycles. When you're talking about introspective awareness, you're never talking about a single cycle. You're talking about, 100 or 1,000 or more cycles that are all going together, melding together, in our experience. So, you might be briefly and at a very low level attending to things on the periphery of awareness, but you might be for a very long time, 100 cycles, for example, be attending to something that's the focus of conscious attention. So in the LIDA model, all of that would have attention associated with it, but some of them would have a lot more attention than others.
So if you have more cycles, cognitive cycles in global workspace, it means that it's more like in the center of attention and center of consciousness. So you're aware of it. And if it's like less cycles, then it's still in consciousness and you still have some attention, but it's you're less aware of it. It's like more
for example, yeah, exactly.
Okay.
So you still have, where is it? Hold on. In global workspace theory, you still have if you see in the center of this diagram, you have conscious experience and you have the fringe, which is the periphery of awareness that you're talking about. I think that's what also Dina was probably getting at with when she was asking about awareness. I don't know if that's right. No? Okay, well, anyways, that's Nir's point. So,
that's true.
Not exactly. I'm really interested in the idea that, what makes us human is our ability to use symbolic thought.
Oh, yeah.
And I've always had a problem with that approach because I have non-symbolic memory. From before I could use symbols as a child, so I'm kind of feeling that out. And it's also, I wanted to make sure that I understood in this theory what consciousness and awareness mean. Because I have an everyday use of those words that are different than the theory.
So what you're aware of at any given point in time is going to be over multiple cycles and broadcasts. So when I talk about, say that I'm aware of this situation, this is, I'm talking about hundreds or thousands of broadcasts. And, whatever is going to be the focus of conscious experience is going to be let's say 90% of those broadcasts. And then whatever's on the periphery or fringe is going to be whatever, 10%, say, of the broadcasts. And that's going to be one of the important differences.
Dina, what your experiences without symbols? What do you remember? What can you give an example? You're on mute.
I'll tell you what I think. You may dismiss it, but to me, this is the best way I have of understanding it. So I used to have recurring dreams of flying, but it was never through flapping or having wings or anything like that. It was always going like this, like going like this, and it would make me go up, right? So I realized that's what children do to move inside the womb. So I'm pretty damn sure those were pre-language memories that made their way into my dreams.
Okay, maybe.
Yeah, so, well, anything that's non-symbolic is, most of our situational representation is going to be non-symbolic, and I think the sense that you mean, insofar as it's non-linguistic and all that. Yeah, so most of what we're conscious of has very little to do with language or anything. Yeah, so that's certainly an aspect of it. And then once you get a conscious broadcast, that's how you can take actions, and that's how you can also learn. So actions are never taken consciously in the LIDA model, never.
And actions does never, what?
Yep, yeah, actions are never taken consciously. And that's actually, that's actually comes straight from William James from his idiomotor theory, which has been integrated into the global workspace theory. Basically, consciousness is a broadcast, right? What happens to that broadcasted information? Well, hold on a sec. So it gets sent to things like procedural memory and action selection, which are all unconscious. So you get conscious content, and then you have schemes for actions, for example. You have schemata for what to do in a certain situation that you've learned. A lot of these schemes are just learned through repetition and habit and all that. And those basic schemes, their variables are bound through conscious content. So I have a scheme, for example, catching a ball, but the scheme has to be filled out with the specifics of my situation right now in order for me to really catch the ball, right? So not only do I have it's basically like a template. So I have the template for the action, and the conscious content enables me to fill out that template and actually grab it. All of that, from the template to all the way to the sensory motor action and execution, all of that is unconscious. Why? Because it's just the content that you're broadcasting. It's not, you're not choosing, you don't choose templates to take. You don't like, think about grabbing a cup. When I grab a cup, I'm not controlling the muscles in my digits directly. I have a general command, a general sense that I want to grab it. That's it. That's what's being consciously broadcast. And then I get feedback as I actually do it. I get feedback from my hands that's proprioceptive, and I feel it. That's what I'm conscious of. But I don't consciously say, okay, move this group of muscles 1 degree over and whatever, right? All of that is unconscious. When I think about an action and what I want to perform, let's say I'm deliberating over whether I want to talk to Neemeh. So I think about, well, do I really want to talk to Neemeh, or do I not want to talk to him? Here's the pros. I do. Don't worry. Yeah. Here's the pros. Here's the cons. you say, okay, well, that's conscious, that's deliberative. Well, what's happening is you're talking about multiple cognitive cycles, and you're choosing to focus on certain options. All the options are generated unconsciously, and you can just consciously focus on some more than others. And when you focus on some more than others, that makes it more likely that you'll do that thing. So yeah, and that's basically how you get actions.
Nice.
So hopefully it's a little bit clear of what the functional role of consciousness is. You know, I briefly said what it was in global workspace theory, but hopefully you get a better idea of how it actually plays a role here. And also, because you get content that's broadcast widely, other modules can learn when you get consciousness. You know, so you can learn to associate this thing right here with the word cup. But it has to have been consciously broadcast before I learned that. You know, the only kind of unconscious learning that you get is priming, unconscious priming, which is, it's not really much of learning at all. So.
Hey, Zach, could you give me a brief overview of how LIDA fits into current AI real world work? Like, is it the primary model that's being used, et cetera? And then maybe, oh.
Yeah, it's definitely, so cognitive architectures are a big area of research in themselves. There are a lot of different cognitive architectures. Some of the biggest are ACT-R and SOAR, especially ACT-R. And none of the other architectures really have consciousness. LIDA is, it's a smaller model as far as how many people work on it. So yeah, it's not a huge one. It's been worked on for the last like 30 years or so, but yeah, other ones are more popular, like ACT-R, and they don't have consciousness, or at least functional consciousness. So this is the only one that does. So that's the kind of place in it. It's been used to simulate some neuroscience experiments. It's been used to control a virtual robot. It's been used to create virtual or computer agents that respond to people. It was actually originally developed as a project for the Navy, but that's how it got its start. The Navy wanted a system that could automatically respond to people for a certain task, and the creator of the model said, oh, well, we need consciousness to do that. So that's how it got started. But yeah, that's the kind of general place in AI and everything. Also, Bernard Bars, who, you know, is the main proponent of global workspace theory, developed it, and all. He's also been pretty active in LIDA and has, you know, papers published together on LIDA. And so there's...
Zach, did the LIDA implementations seem to have something like consciousness more so than the other schemes?
Functionally. Again, there are no claims being made about phenomenal consciousness. Probably there is no phenomenal consciousness at all. There's no way to prove that, but yeah. Does it seem more lifelike or anything? You know, that's an interesting question. At the level of real world agents that have been designed, I don't think you could really say one way or the other. That's premature.
And when you say there's probably no phenomenal consciousness, do you mean at this stage in our abilities, or period, because of what we're trying to do?
Oh, I mean that, so LIDA agents, which are basically like real world applications of the model that you see in front of you, nobody thinks that they experience anything. like they have the functional and computational aspects of consciousness as posited by global workspace theory. Consciousness has a functional role in the system. It gathers salient things together and makes them available for other modules, and it allows action to happen, and it allows the system to learn. And so that's the functional role it plays, but probably is not aware of anything, but there's no way to prove that.
I think my question was, is that a limitation of our current skill set?
Oh,
Are the users
yeah.
of LIDA like hoping that this will become a conscious model, like a true model for phenomenal consciousness at some point?
Yeah, nobody in the research group is thinking about that. I'm probably the only one who's been asking questions about phenomenal consciousness, and yeah.
Yeah, the problem is that in order to solve it and to have phenomenal consciousness or qualia, then we need a good explanation. How did we solve the hard problem, right? Like, and they don't. I mean, they don't try to do it.
No,
if I
they don't
understand
try.
correctly.
No, yeah. It's just trying to. It's like, think of what a neuroscientist is trying to do usually, except for Neer. Neer wants to explain everything with a theory of the brain and a theory of qualia, but most neuroscience is not trying to figure out why you have experiences. It's just trying to figure out what regions are communicating with what regions, and what kind of activation do you see. And in the same way, LIDA is just trying to see what are the computations being performed. So to me that's a limitation, but I don't think it's a damning problem. It's just something that is extraordinarily hard to do. I don't think that a LIDA agent would be phenomenally conscious. Why? Because I just don't think that there's a good reason to believe that it is. I mean, there's no motivation to believe that it is. Maybe. We couldn't prove it.
So one thing that we can ask is, according to my suggestion of how to solve the hard problem with the relativistic view,
yeah.
Does it stand, let's say, does those conditions to have consciousness or phenomenal consciousness, according to my theory?
Yeah.
I'm not sure, even now, after I saw how it should work, do we have here, like, if you remember, we should have, like, to create this bubble of reality, so to create this space of representations.
Yeah.
So all the inputs and everything is in this space, and also this, like, a center system, it's self or something like that, that knows how to read all the representations. And it has all the, like, the semantic there, all the meanings, let's say. And then it should be enough to create this, qualia. But I don't know if LIDA does it do it or not.
I think that it's like, in my mind, it seems pretty clear it would be just that we're very new at it, and that LIDA or some other model of consciousness could produce a phenomenal experience in the way that Neer has just described.
Yeah, it's possible. I mean, if we're right about the computational elements, we should be at least part of the way there. That doesn't mean that we're all of the way there, and I don't really have an answer to whether it's a limit of the technology or whether it might be a limit in something else. I don't know. Last time I proposed the idea that we don't have any way of knowing whether biological or biochemical matter is important for consciousness or not. I don't think we know whether it is or not. If LIDA has all the computational elements right, but it doesn't have biochemical embodiment, maybe that it just won't have qualia. We just don't know what the answer to that is, and maybe it would. I don't even see how we would answer the question as to whether it's a technological hurdle or whether it's like a hurdle in nature itself. I have no idea.
That goes back to the discussion we had last time, you know, when I said that I hear a human bias in there.
Mm-hmm.
And I think it's still the same, because for all real purposes, I am the same as the black box. You can't know that I'm real. You can't know that I have phenomenal consciousness. You can only say that because you are human and you experience this thing that you're going to call phenomenal consciousness.
Mm-hmm.
So it's really sort of equivalent to the LIDA creature as well.
Mm-hmm.
You know, you can never get inside my head. I can tell you that I have phenomenal consciousness. Same with that creature. It can tell you, but you're saying because it's not a biological entity, you can't trust what it says. Maybe humans trust humans more, and that makes a lot of sense. But that's the thing.
So yeah, I think so. I have two responses. The first response is that there are differences between how, let's say, a LIDA agent on a computer or in a robot. There are differences in how its consciousness and how human consciousness is being performed. The differences that we can measure, even though at an abstract computational level, they should be equivalent. You know, functionally, they're still doing the same thing. But the global synchronization that I talked about of neural assemblies is not happening in a LIDA agent. At least in most LIDA agents. A LIDA agent could be anything, theoretically, but like most LIDA agents are computer programs or something. At least today they are. Those are, you could put it in an MRI and you could say that there are real differences, you know. In an MRI, one of these is showing evidence of global synchronization and the other is just showing us silicon. Now, according to the global workspace theory of consciousness, that kind of synchronization is pretty important. Whether it's a deal breaker or not, that's a good question. I don't know. The second response is that I don't, in a way you're right. You know, it's in philosophy, it's called the problem of other minds. You know, how do you know that other minds exist? How do you know that other people aren't what are called philosophical zombies, which is basically like a LIDA agent? Like, how do I know you're not just a sophisticated LIDA agent that responds to me and has functional consciousness but has no awareness? Well, the answer is I don't know that. But I do know that I am phenomenally conscious.
Right.
That's what I'm saying is the human bias. It really, like we're using this term phenomenal consciousness. We have a feeling that we are X, Y, or Z. It's just a privileging of human experience, and we're trying to develop a model of cognition. It shouldn't only depend on being human. And then to address your prior, there were two parts to what you said. I think that the prior thing that you said is about our current abilities, because you could have I can imagine a non-organic, you know, like silicon-based, very sophisticated system that can do those things. You know, that's all.
Yeah, I mean, I could imagine a sophisticated system like that too. It's exactly what LIDA is a sophisticated system like that. But so it would be human bias if I claimed that the only thing that's conscious is me. That would be a weird claim to make, that I'm the only person that's conscious. But as far as knowledge is concerned, absolutely certain knowledge, The only absolutely certain person that I know of that has phenomenal consciousness is myself. I can't literally experience phenomenal consciousness in you or in Nir or in a LIDA agent. I can only infer it. It goes beyond inference, but I can't literally see that. I can't literally prove it in any way. And that's what I mean when I say that my worry is epistemological. It's about what we know and what we don't know, not about what exists and what doesn't exist. It's just that I know that I have phenomenal consciousness. I also know that I'm a biological being.
Yeah,
So I have no idea whether something that's not like me, I can say that it's probably very certain that things that are like me physically are probably like me in the mental way. You have the same kind of embodiment that I do. You have basically the same physical, chemical, organic composition as I do. You respond the same way. So it seems to me from a subjective Bayesian perspective that there's a high probability that you have phenomenal consciousness, but I simply have zero idea of whether a non-biological thing could be conscious or not. We simply don't know. I don't think you know, and I don't think I know.
exactly.
Yeah.
So be careful about saying that it doesn't have phenomenal consciousness, is what I'm saying, because those human biases have been used to deny that in other non-human biological creatures, like for very malicious purposes. So I hear that same kind of bias welling up in these discussions too.
Oh yeah, I mean, maybe that's an artifact of my language, but that's not what I mean. I think that you could not prove to me that biological embodiment is not necessary. And I could also not prove that it is necessary. I just don't think that we could prove it either way. Maybe someday in the future, we would have a way of knowing.
So this is,
yeah, that's also for you, Nir. I don't think that you could prove it. I think it's a postulate, but it's an unproved postulate that only computations are necessary.
Yeah, it is a postulate. Mm-hmm. This is how you start, and later on, you try also to, to think of an experiment and to check it empirically.
I don't think that there's probably a way to check it empirically. And it just goes back to the whole relativistic paradigm that you talked about, that you actually have to be the system to know whether it's phenomenally conscious or not. So,
but first of all, so notice that this relativistic notion is exactly what Dina is saying, that you don't need to, it doesn't have to be biological anymore. It just say that if you do have this zombie that looks like Dina and do all the functional parts that Dina can do, and it's has all those representations and meaning, and and can do all those manipulations and and to respond to questions and say things like, yes, I love your theory, it's amazing. Then I would say we cannot distinguish between that and their phenomenal consciousness. And according to this relativistic principle, it has to be that it's the same. That, we created here a new property. Voila. Right, so one good thing about it is that now we do have a theory that we can check. And if the theory is correct, then we can say, well, we don't need the biology part according to this theory, if it's
but you can't prove it
correct or not. So, in order to prove it,
it's an unproven postulate.
So again, what I said last time, I think that every time that we have a relativistic system, we know we can have a way to do the transformations.
Mhm.
So and so then I can put this machine and be Dina or something like that.
Yeah, but
Uh,
that's not a real experiment. You can't do that.
I think we will in the future, in the future. In theory, it should be something that we can do. But okay, let's wait and see.
Yeah.
Maybe let's go back to LIDA. So,
Yeah.
is it working better
Yeah.
than a different AI? I mean, except of the conscious part, which is the most interesting. But like,
Yeah.
let's say about cognition, it tries to mimic the brain more or less.
Yeah.
Sorry, not the brain, the mind, the
Yeah.
human mind. So, is
Yeah.
it work? I would suspect it would work better than other AI schemas because, it's trying to mimic something like the human mind. So
Yeah, that's so this stuff is really hard to do. There have been a couple experiments that have been replicated from neuroscience, and LIDA got similar results. That's about as best as we can get to answering what you're saying.
similar
as far,
similar
Yeah.
results to humans, do you mean, or to
Yeah,
other
yeah,
AIs? What do you mean?
yeah, similar results to humans. That tells us there's probably at least like something good going on. As far as other AI architectures, I think they also perform very well without having functional consciousness. But at the same time, they're not plausible as models of human cognition insofar as they ignore the difference between conscious and unconscious cognition. So as far as getting good results, I think there's a lot of other AI that gets very good results. There's, in fact, the stuff that gets the best results is machine learning, which has zero resemblance to humans. But what we want is something that doesn't just work well, but that also is plausible in humans and other animals and other agents. So yeah, no, there's plenty of very good AI that does great explanations, but if it doesn't have an aspect that's conscious, then there's something missing.
I do have another question about this model. It's not a model, right? It's the architecture, you call it, this cognitive cycle. So you said that we have lots of cycles, like hundreds of thousands of cycles, right?
Yeah.
So each of them should do an action, because it sounds like a lot of actions. I don't know, but
yeah. There's always an action that's being selected. It might be something like move your arm. It might be something like move your head. A lot of these things, like when I'm talking to you, I'm doing a lot more than producing sounds. I'm moving my body, I'm swaying, my eyes are moving. Tons of actions are being taken at every second. So yeah, there are a lot of actions that are being taken at every single moment. And that's basically because we're embodied beings. Our bodies are always in movement. Even when we're standing still, there's actually very subtle swaying movements that we might not even be aware of that are going on. So yeah, there's always an action being taken.
And I have another question. The basic idea of this consciousness, access consciousness, is this broadcast to all global broadcast.
Yep.
But in order to create this current situation model, don't we need already this very global integration or something from lots of different areas in order to create this situational model, which is very... So isn't it already very global and broadcast or something like that?
what you get with the current situational model is you see a lot of modules where my cursor is are helping produce that. So you get different forms of long-term memory. You also get sensory memory, which is like early sensory processing. You have several other things as well that are going in to make that model. So it is a pretty central thing, but it's still not conscious. In order to be conscious, first of all, only aspects of it could become conscious, you know. As I said, you're only aware of a smaller portion of your immediate situation. You're aware of a smaller portion of your situation than what you know about. So if your phenomenal awareness, for example, at this given millisecond right now, is you focusing on the screen, you still have a broader situational model, even if you're not immediately aware of it in this cognitive cycle, that you're in a room and basically the distribution of things in your room, but a lot of that remains unconscious until it's consciously broadcast, and probably a lot of that comes in and out of consciousness, you know, but you're probably never aware of the entire situation at a single given time. You're only maybe aware of the whole thing if you look at a long time scale. Yeah.
Okay.
So the central area is unconscious, but yeah, aspects of it can become conscious. Because what would it mean if you were conscious of everything in your situational representation? It would mean that I am phenomenally aware of everything going on right now. I know, you know, I have a consciousness of the positions of every single thing while I'm talking to you, while I'm looking at my cat over there, and that's just not how it works.
No, but my question wasn't, yeah, this makes sense. My question was about that already to create this unconscious situation, you need a lot of global synchronizations or a lot of global integrations.
No, you need local synchronizations. In the brain, that would be something like local neural assemblies, but it's not yet a global broadcast. So you would have tons of local processes, and they would be creating a kind of coherent image of things. Okay, but that's still a relatively localized thing. It's still not global in the sense that it'll allow us to be aware of it, and it'll allow us to take action on it, and it'll allow us to learn from it. You can only learn things when they become conscious. Without consciousness, learning can't happen, except for like unconscious priming, which only lasts for, you know, maybe a few seconds or something, or maybe minutes at most.
Okay, I need to think about it. Okay.
Yeah.
Interesting.
Zach, I had a question about the term, like the cognitive cycle or the cognitive atoms. Is that referring to like the totality, and there's only one cycle at any given moment, or do you say there's multiple cognitive atoms simultaneously running in parallel?
Yeah, there's multiple running in parallel. I mean, well, look.
So you can call a cognitive atom for any of these like parallel loops that are going on.
Look, they're happening one after another. So in that sense, that you could say they're sequential, but like they're happening really rapidly after one another. So you get you know, when I see the keyboard in front of me, that's going to initiate a cognitive cycle. Okay, but I'm not going to wait until I take action upon that keyboard to be aware of something else, you know. I'm going to keep looking at new things and keep being aware of them. And so you're just going to have one thing going after another. So you'll be just massively processing a lot of things together. But the cognitive cycle itself is, they are kind of sequential in that way. It's like one after another after another. They're just all jumbled up, so to speak.
Okay. Okay. And then,
so as I'm talking to you right now, you know, I wouldn't even know what the number is to put on it, but there's tons of cognitive cycles that are going into this speech. If you look at one cognitive cycle, in a person, you couldn't really pick a single one out. I mean, you could look at the brain firing and say, okay, there's a global broadcast. But it's pretty hard to really pick out a single cognitive cycle because they're all happening one after another.
so you can use the term to cognitive cycle either to refer to a sub portion of like the loops that are occurring, and they can occur in parallel, or you might be using the term cognitive cycle to refer to the whole collection of all the different loops occurring at once.
Oh yeah, a cycle is just a single loop.
Okay.
Yeah, it's one single loop, and basically I brought you through the way a single loop works. But you know, obviously, real cognition works with tons and tons of loops. It's basically the movement from perception and understanding to consciousness to action. That's what it is.
Okay.
Uh-huh.
So you can use the term either it can be also parallel things, or sometimes it sounds like you're saying it's a strictly serial thing going on. Sometimes it sounds like you mean it's multiple different overlapping things occurring.
So the modules are all parallel processes themselves. You know, they're all massively, a lot of them are implemented through things like neural nets or the copycat architecture. I mean, every module has its own computational format. But as far as the way, because consciousness is a part of how this works, and consciousness is functionally serial, it makes the cognitive cycle into something that's at least functionally serial. Insofar as like you get one after the next. But all the processes that are going on are themselves parallel, if that makes sense.
Yeah, like I see like there's multiple parallel things feeding into the workspace, but you're only ever aware of one total package at a given moment, and then the next moment it's going to be a whole another totality that's still being fed into by multiple parallel things.
Yeah, exactly. Yeah.
So like the current, just to make sure, so the current situational model, this is a model that it's like parallel. So you create a couple of those, I guess, like lots of information inside until you reach to some coherent model or something.
It's continually being updated and changed at every single moment. It doesn't really do anything. Every module has its own function. So attentional processes are going to look at what's going on there and say, oh, that's interesting. This is interesting. And bring it to competition. So yeah, it's just doing its own thing in parallel, but attentional processes are going to make a few of those elements into salient things that compete with one another.
I see, it makes sense. And then because it will be serial, then the next step now will get all this broadcast information. So now the current situational module will be more like more coherent, or will converge into one, I don't know, one conscious situation. I don't know, something like that, if I understand correctly.
So
there'll be like a convergence here, maybe.
So when you get a conscious broadcast, you know, that's going to feed back into your current situational model. You know, once you're aware of, once you see the situation, that's going to be part of, it's going to loop back to sensory memory eventually. And, you know, you're going to be aware of what's going on. And that awareness or consciousness is going to change your model of what's going on, right? So it will modify, you know, your current situational model, certainly. Yeah, so there's like feedback effects from consciousness onto your model of the world. But again, you're not consciously aware of everything in your situation and yourself and all of that. You're only aware of a portion of it at any given point in time.
Yeah.
I had a question about the term broadcasting. Is it?
Yeah.
Is this through? Do they mean this is like action potentials firing down nerve tracks? That's the medium or the mechanism of broadcasting, or is it? Or are you actually suggesting there's some sort of like field-based broadcasting? Because I mean, the term broadcasting sounds like, you know, radio waves streaming out of an antenna.
Yeah, definitely not radio waves.
Yeah, not radio waves, but I could see like field potentials conducting information in some way, or or do they mean strictly through action potentials? Just
So broadcasting it's really in the strictest sense, it's a metaphor. That just means that if you want to talk about brains, it means that other disparate regions in the brain are going to have access to the content of one region, right? That's what the metaphor is trying to capture. Now, how does that work physically? Well, it's postulated that it's mediated by the theta gamma wave coupling that I talked about earlier. So at least it's thought that broadcasting is really happening through global synchronization. That's it's mediated through long fiber neurons, but it's really just global synchronized firing. That's the postulate, at least.
Those like theta and gamma waves are basically, you're talking about EEG frequencies, right? Or
yeah.
I mean, I almost see the EEGs are like an, I don't know, epiphenomenon, or like they're the product, but how can you're actually saying that the brain is talking to itself through the EEG fields?
Well, no, it's more like, yeah, it is more like the product, but it's, at least that's indicative of the kind of coupling that's going on.
Okay, so it would be indicative, but it's still like action potential firing. That's the way the brain reads.
I mean, that's mechanistically, yeah.
Okay.
Yeah.
Yeah, I can add here that what I learned from Ben is that this broadcasting is through the fibers, the long fibers, you know, the white matter of the brain.
Yep.
So you have this area, or like lots of areas in the brain that connect to each other with an architecture of long fibers. And this is the broadcasting, you know, even without speaking about EEG waves at all, just broadcasting as an architecture of areas all along the brain that just have long fibers, and that's why they can connect.
It's the hierarchy. It's what I mentioned in this slide. It's through the mediation of long fiber pyramidal neurons. Yeah. So basically what you said.
Zach, do you have an example of how it works? Like something to see how LIDA works in real life? Like
I have an example of I really need to be closing this up.
yeah, sorry, right, yeah.
Yeah, let me just briefly say, I'll give you a really quick example and then let's wrap this up.
Sure. I mean, do you want to continue next time, or did we finish more or less everything? And it's
yeah, we finished more or less everything. I can just give you a really brief example, and then so let's say I'm conscious of my hand. Okay, how does that work in the LIDA module? What does that mean when I'm sitting here and I'm looking at my hand and I'm conscious of it? What does that mean? Well, first, the representation of, or the model of my hand in my body, it's going to be produced in what's called the current body schema. And it's gonna feed into our current situational model. Okay, so it's gonna help produce that. But that's like our proprioceptive model of the body is there. But that's not all that's needed to be conscious of the hand. There's a lot of things that are going on. So you have a hand that's a proprioceptive model. You also have the hand as it is in your situational model, which is building up a representation. Okay, my hand is part of my situation as well. I also have.
What do you mean situation?
What's that?
What do you mean by situational model?
Yeah, my current situational model, which is my model of me and my environment and everything that's going on.
Ah, yes.
Yeah. I also have a hand represented there, slightly differently though. It's a hand in context, not just proprioceptive. I have long-term memories of my hand that is more semantic in content, for example, or recognitional or visual. Let's say it's visual. Well, that's going to be recognized in a different area of the model. So here, I've already showed you 3 different representations of the hand. And that's what I want to get at is that to be conscious of one thing, it's going to actually be pretty complicated what's going on. So let's say I start by looking at my hand. So it's going to come in, information is going to come in from sensory memory. And it's going to be represented proprioceptively up here. Now, that proprioceptive representation of my hand is going to feed into my current situational model, which is potentially conscious. You know, it's my hand. It's not just my hand, but it's my hand in front of the laptop, in front of me. Okay, that's what it means. Sensory memory is also feeding into my recognitional memory at the same time, where I recognize, for example, visually a hand. Visual and proprioceptive information is very different, right? So these are happening in different places in the LIDA model.
And
now,
also in the brain.
And also in the brain, yeah, of course, yeah. Hopefully, if LIDA is doing things right, all of this should be translatable to human brains as well, hopefully. So the visual representation of the hand is going to also feed into the current situational model and say, okay, yeah, no, it's my hand right here in front of the laptop, and here's the visual information, and here's the proprioceptive information. Now we have all of that starting to come together. But I'm still not, let's say, conscious of it yet. It's going to, because let's say it's salient. You know, it captures attention, right? It's right here in the center of my attention. So it's going to, let's say it wins or it's in the competition for global broadcast. So here we have what's called, what I said was called a coalition. You know, it's the structure in the current situational model plus attention or attentional processes. So here we have yet another representation of the hand. It's slightly different again. Now, that's if it wins out the competition, which if I put it right in front of me, it's gonna win. Okay, it's because it's just kind of something that's highly salient because it's right in the middle of my visual field. So it's going to be consciously broadcast. So that means it's going to be made available to all these different modules for action selection, because then I'm going to take an action based upon what's going on. You know, in this case, I'm talking about my hand. You know, so the action is talk. So that action is, you know, gonna feed through, and there's going to be a change to the environment once I take an action. Usually, not all actions are external, but at least let's say in my example, I move my hand. Okay, so it causes a change in the external environment. I move my hand. So we also have the real hand in the real world that's changing. So we have 1, 2, 3, 4, 5, at least 5 different hands that we're talking about. Each of them is different in a certain way. This is basically how you would become conscious of that hand and take actions upon it. So and the point being, it's enormously complex how that happens. And even this is, you know, a vast simplification, but yeah, hopefully that clarifies how you're conscious of things.
And then they implement this in a real world, like in the Navy or something.
So that was the original application, but it's since grown, you know, far out of that. So no, I don't think it's any longer used by them. But basically, the model you see in front of you is used as a schematic to produce what are called agents, which you create for specific purposes. So, for example, some of them are made for experiments. Usually, you tailor these agents for specific purposes. You know, it really depends on what kind of agent you want to build. You know, there have been virtual robots built. There have been basic experimental modules or versions that were just meant to test experiments and see how the experiments would run in a LIDA agent. There have been some that have been software agents that are designed to interact with people. It really depends what you want to build. Yeah.
It will be nice to see like one agent, like to see how it goes, you know, like let's okay, for next time.
Yeah. So there's not like something spectacular to show you. You know, there's results of it's mostly software. Yeah. So it's maybe a little less spectacular than you're hoping for. You can read about the results of what happened with the software in the papers. You know, there's some 60 something or 70 papers available by now. And the software, at least some of it is available online, but you know, it's basically code.
Yeah. So, but they can interact with people and do something, action in the world, right? I mean,
yeah, depending on the agent that you're building. Yeah. So that's in a nutshell the LIDA model. You know, it is a computational model, and agents have been built. Some of it remains theoretical. So some of the aspects that you see still are pretty theoretical. Yeah, it's an ongoing project. It's been ongoing for the last 30 years. So.
Zach, did I understand that you are involved in the working group for LIDA?
Yeah, so this cursor right here, where I'm circling around current body schema, is what I've been doing for the last year. It doesn't look like much in this diagram, but believe me, it's been a lot going into that. So yeah, so I've been working on helping them develop basically an agent's proprioceptive model of itself.
And was I correct that your background is philosophical?
Yeah. I don't do the computational stuff. They do. I do the theoretical stuff. Yeah.
So what do they need the philosopher for that? I mean, isn't it, don't we know models from cognitive science about body schema?
Yeah, so, well, what is a philosopher's role in cognitive science? I think it's similar to the role of the theoretical physicist who takes a step back from experiments and says, okay, well, how does this all work together? What's the big theoretical picture here? I would say that is what the role of the philosopher is in cognitive science. So I don't see the philosopher as outside of cognitive science. I think the philosophers, well, most philosophers are literally outside of cognitive science, but at least the philosophers who do work in cognitive science, I think our role is kind of like just the theoretical role. How do things fit together in the broad picture? And that can actually, it's a useful and unique skill. Most cognitive scientists are trained in very narrow topics. That's just the way it works. And sometimes it's really useful to have somebody who can say, okay, let's talk about the big picture.
Yeah, that's true. Yeah. So you speak with them about the big picture of body schema.
Yeah. I mean, I've been working with them on, the theoretical aspects and how that would work in LIDA and everything. And as far as I'm concerned, I don't want to do the coding. That's what they can do, the coding, and that's fine for them. But I'm interested in, the more higher level relations. So.
Very interesting. Great, thank you very much. I think, Zach, other people want to ask questions? Wow, yeah, it was very, very interesting.
I have a bunch of questions. I have a bunch of questions, but they'll wait till next time. Talk.
If Zach can come next time, then we can ask him then.
So thanks for dropping in. I hope that I was able to communicate this in a reasonably non-technical way. I've tried to make it as non-technical as possible. I know that's not really feasible, but I hope that it's at least partially intuitive what's going on.
I think you did a great job explaining it.
Thanks for the talk.
Yeah, no problem.
Now, next time we will continue. We will go back to reading the papers according to the folders that Ben gave me. So next time we will go back to continue to read about the mind and the structure, the architecture of the mind. Like today we saw in LIDA how we take this architecture and implement it. But so next time we will go back to the studies of the actual, cognitive science and mind and everything. And I will send everybody the paper.
Hey guys, before you all head out, I'm trying to put together a discussion group for Burning Man in the Sparkleverse.